strategy, and let's learn about the last topic for this lecture is the productivity. So in simple terms, productivity is nothing but the amount of output you get from a certain amount of input that has been put into the process. So it is a measure of effectiveness effective use of resources, usually expressed as the ratio of output to input. Yeah, that's what we discussed few seconds ago. So in general terms, for any organization, the goal is to maximize the productivity, meaning getting more and more output from either same amount or reduce the input, less amount of input that goes in. The key rule or the golden rule is, without stressing your resources. So without stressing out your human resources or equipment or financial resources. So that's the goal. That's a continuing challenge for all the organizations. So that's what productivity is. Productivity measures are useful for tracking and operating units performance over time, whether it is consistent improvement, improving or degrading. And if it is degrading, what can be done to bring it back to keep it normal? The second one is productivity measures are useful for judging the performance of entire industry or the country in general. Yeah, like from both these pointers or definitions, what we saw is productivity has vast scope, various scope. It can be for the entire country or industry or for your local specific operation you are working for or specific process you are working for. Yeah, so the scope is it can be applied anywhere. Why productivity matters? Yeah, well, again, it has direct implication on the profits and revenues your organization making. So higher productivity is linked to higher standards of living. Yeah, that's as per the definition. As an economy replaces manufacturing jobs with lower productivity service job, it is difficult to maintain the high standards of living. And again, this is taken from a textbook, but very true. And it is just specific to overall economy or manufacturing job, but it applies to every job sector. Higher productivity relative to the competition leads to competitive advantage in the market place. Very correct. So yeah, that competitive advantage can be tied down to pricing or profit effects. For an industry, high relative productivity makes it less likely it will be supplanted by a foreign industry. Another very true. Yeah, if your company or organization is profitable, making lots of revenues, making lots of profits, highly likely, foreign industry won't be able to compete with you. Some of the productivity measures or simple formulas. So like we said, saw before, like in simple words, productivity is nothing but output divided by input. So that's your first formula. And if we still separate it down or go into much more granular level or partial measures, its productivity is output divided by single input, or in other words, output upon labor or output upon capital. However, like what part of the process you are looking for, you can use the respective formulas, or you can create your own. Again, keeping the most basic thing in mind, it's like output upon input or output upon single input, and that input can be anything based on the criteria you are looking for. The next, I will say, variant of productivity is a multi-factor measure. On a higher level, same output upon input. So output upon multiple inputs, and these multiple inputs could be output divided by labor plus machine or labor plus capital plus energy plus machines and so on. So a total measure is goods or services produced, usually either quantity or sales amount divided by all the inputs used to produce, and you'll be using the respective units, which is quantity or the sales amount with respect for the inputs also. Some examples of partial productivities are, labor productivity, machine productivity, capital or energy productivity. And few minutes from now, in the last like 6 or 7 slides, we'll be solving lots of problems and we'll touch these topics. But yeah, in general, these are the most basic types of partial productivities to keep in mind: labor, machine, capital, and energy. And here are some more elaborations. So labor productivity is nothing but it's units of output per labor hour spent, or units of output per entire shift, or value added output per labor hour, and so on. Same is the case with machine. So it's units of output per machine hour or dollars value of output per machine hour. Same capital productivity is units of output per dollar spent. And for energy, very similarly, units of output per kilowatt hour spent. Yeah. Let's see a very simple example, and believe me, this is very simple. And oftentimes, well, another thing is while dealing with productivity issues or while trying to understand the productivity of your entire organization or your department or process of your department or each activity of your department or sub activity of your department, most of the problems are could be solved using simple mathematical expressions. Yeah, addition, subtraction, division, multiplication, and so on. So that's a key thing about productivity. So this is a very simple problem, and as we go, we'll increase the level of difficulties for the problem and try to cover the several aspect or several problems or several scenarios that you may be facing on a daily basis, or if you're not using it yet, you can start using it so that you understand your baseline, your current state, and that will give you some food for thought about how to improvise from there. So the very first problem. So here are some given details of a given, I will say, process or operation. So in a given department, the number of units produced maybe per day, per week, or per month are 5,000. And the standard price of each of those units is $30 per unit, each of them. Labor input is to make those 5,000 units. The total number of labor hours spent are 500. And the cost of labor hour is say $25 per hour. Cost of materials used to make these 5,000 units is $5,000. And hidden cost, cost of overhead is twice the labor cost. Yeah. So again, looking at here, the top two lines are telling us something about the units produced and the cost related. And the last four are, you see, labor, material, and overhead. So indirectly, it's telling you like what is the input that is going in. So definitely labor is one of the key input, material is another key input, and overhead spent in the whole facility is the third input given. Yeah. So this is a case of, if we go and check the formulas, it's a case of multi-factor measures. So yeah, the units produced 5,000 is your output. And again, cost is given, so you can get the cost out of it. And there are three different inputs, labor, material, and overhead. Yeah. So let's see how to solve this problem. So yeah, like I said, this is a case of multi-factor productivity, multi-factor input that is going in. And yeah, like here is in this slide, a straightforward calculation and answer is given. But I will highly recommend you all to use Excel. So I will just pull an Excel sheet that I have already created. And again, like at the end of this lecture, I'll be uploading this Excel sheet in our lecture thing. Here, let's see. Canvas. Yeah, here you go. So yeah, maybe yeah, in this chapter 2 module, yeah, this today's class, I'll be uploading that Excel file, and which you can use to do the calculations and get your answers. Yeah, and on top of that, there will be another like homework problem which I haven't activated yet. I mean, there are no problems within this, but based on all the problems we'll be solving as a part of this class, I'll be adding those numerical problems, and then it will be, this assignment will be open. Yeah, so do use the Excel file as much as you can to get the calculations, because I will say it's about getting you guys like the habit of using Excel to solve these kind of problems. Yeah. So the very first is, the units produced and standard price is given. So based on that, I can get the cost of all the goods sold or good cost of all the goods produced. Yeah. Or in simple terms is the output. So if I want to get a dollar amount for the output, what I'll be doing is, you see, the unit produced multiplied by standard price. Yeah. So this will be the very first. So this is my output. So equals to 5,000 units multiplied by a cost which is 30. I might get an error because it's not purely a numerical value over here, but let's see. Yeah, like I expected, there might be. So again, here I will change something. So standard price per unit, and I will take the text out of here. 30. Now I'm getting. So the total cost of goods produced or cost of goods sold, whatever it means, is given by 150,000. So that's how I calculated. Next one also labor input. I will say bracket hours. URS. Oops. Is 500. Cost of labor. Again, I'll say per hour. I'll copy this thing. Control X. Per hour. Cost of labor per hour is 25. Cost of material 5,000 and cost of overhead is 2 times. Again, all I will say is twice multiple of labor cost. Cost of overhead. This is what it is. And again, let me say wrap it down. Yeah, this also maybe all of them wrap it down. Perfect. So yeah, the cost of goods sold or the output is this multiplied by this. Labor input, so that will give me the labor cost equals to say 500 hours spent multiplied by $25 per hour multiplied by $25 per hour. That gives me, that is my labor cost, $12,500. And the next one is overhead cost. So that's twice of labor cost. Yeah. So again, I mean, you can do it multiple ways, but I'll just do it. Yeah. 2x in bracket. I'll recalculate the labor. Cost of, yeah, hours 500 multiplied by 25. Is 25. Enter. Yeah. So that's twice of labor cost, 25,000. So, and the last is the material cost, which is straightforward given. So my multi-factor productivity, which I'm supposed to calculate as a part of this problem, will be equals to the total, yeah, output, which is 150,000 divided by, again, I'll use bracket over here. My first is the labor cost, which is this one, or I can do a simple sum. Yeah, let's do. I'll be very I'll say specific this time. So I'll say B12, which is my labor cost plus cost of materials 5,000 B6 plus overhead cost here. And this is just too simple to show you. So that gives my multi-factor productivity as 3.53. Yeah. So that's my answer. I'm saving it out here. So that's how I calculate. That's how we solved the first problem and calculated the multi-factor productivity over here. So yeah, with that, we solved the this first problem. Learning some more theory. The next one is productivity growth. Yeah. So this is another type of formula or another type of situation criteria you might come up with to understand the growth over a given period of time. Yeah. So again, the formula for this is current productivity minus previous productivity divided by previous productivity, and it is always denoted in terms of percentage. So you multiply by it by 100%. So again, a problem is given over here. So it says labor productivity on ABC assembly line was 25 units per hour in 2014. So given a year, this was the labor productivity. And for the same line in the year 2015, it was 23 units. So the question is, what was the productivity growth from 2014 to 2015? So in a consecutive year, what was the productivity growth? So again, this is the formula we are using. Current productivity is 25. Oh, sorry. Current. Yeah. So the current is 23, which is for the year, the latest one 2015, and the previous one is 25, which is 20. It's 25. So I'll be plugging in these numbers 23 and 25 in this formula out here, and I get a negative. So technically, it is telling me that my productivity growth reduced from year 2014 to 2015 for this ABC assembly line. Yeah, so that's your answer. Now something, yeah, so previously the examples we saw were, units produced. So it's more of a production type or manufacturing type of product that was made. For service sector productivity calculation, let's see some theory. So this is always difficult to measure and manage because it involves intellectual activity. So oftentimes, suppose there is a failure, say a refrigerator or a compressor fails in a refrigerator. You call the customer service, they will create a ticket, and then maybe as a representative will be available immediately, or they will call back maybe on the same day, next day. Then the representative will try to understand the problem. Based on that, maybe they will refer or read a user manual or a troubleshooting guide and so on to further nail down the problem and so on. They might give you a procedure to follow. Unplug your refrigerator, do these things, and try to plug in and see if so. Lots of activities might be involved. So the intellectual activities might be involved. So that's why the actual productivity can be sometimes difficult or tricky to actual formulate or quantify, qualify, and there could be a high degree of variability. Yeah, so these are the challenging parts. And a useful measure related to productivity is the process yield, where the products are involved. It's a straightforward ratio of output of goods produced to the quantity of raw material that goes in. Yeah, this is a simple definition. So process yield is one of criteria. And when services are involved, process yield measurement is often dependent on the particular process. It could be, for example, ratios of car rented to the cars available for a given day. And I think, yeah, this is a very real for car rental business. This is a very, very important ratio they keep a track of. Second one is ratio of students acceptance to the total number of students approved for admission. Suppose 100 students are accepted versus only 60 decided to actually take the offer. So yeah, it gives a ratio of 60 upon 100, which is 0.6 or 60%. So yeah, this is how you'll be quantifying or the process yield for product as well as service type of uh, industry. Several factors to affecting the productivity are method. Again, yeah, like what is the procedure you follow to make those products or services makes a big difference. There is quality and how you're tracking down the quality, number of scraps produced, or how many times you are able to fix the service issues, or multiple questions or multiple procedures are required or not. So yeah, that's part of your quality. Next one is management. And again, this has a huge scope. It could be subjective term management. So it could be what priority the management is given, what resources they are based on the priority, what resources they are allocating in terms of people, human resources, capital, equipment, machinery, and so on. Same is the case with technology. What is the technology your existing company is using, organization using? Also capital decisions required. So these are some of the factors that affect the productivity. Some examples of recent technological factors affecting the productivity are the new age drones or GPS or smartphones or 3D printing technology, additive technology, RFIDs, medical imaging, which is very precise these days. So diagnosing a problem becomes much more quicker if the imaging is much more precise, high resolution. And again, there is this whole new topic of AI going on currently, and it's still improvising. So these are some factors that could make things much more efficient in coming years. So yeah, these are some examples affecting productivity, technology examples. Measures to improve productivity. And again, there are like a few listed out here. I'll just read through. The first one being develop productivity measures for all operations. So like I say, keep preaching, try to qualify any productivity or your existing process, product, services, or any issues. So clearly qualified, clearly quantified, and you develop those measures for all the operations. Second one is determine the critical bottleneck operation. So again, very, very important. And I think this understanding bottleneck was one of a key thing that was mentioned by one of the student when we were having our introductions in our first class. So yeah, one of my proposal while developing the projects for this class is we'll try to utilize the existing operations of maybe some of the students, and maybe within those operations we'll try to nail down, go to the detail and identify the bottlenecks and try to come up with corrective actions. So yeah, like the second one is improving productivity, identifying the bottlenecks and focusing on the bottleneck is the right approach to move forward with respect to improving productivity. Third one is develop methodologies for productivity improvement, again an ongoing challenge. Next one is establish reasonable goals. Make it clear that management supports and encourages productivity improvement. It's always important to have the support from top. And that's where communication, continuous communication, using some numbers, facts, figures of the existing process current state to win that support is critical. Next one is measure and publicize the improvement. It's a very important part of the any continuous improvement organization who focus on continuous improvement. It's to like any small wins you have, you try to publicize it, show it as a user case, show it as an example to your entire organization. And again, this is a way to kind of help the entire organization, other people who are not doing it, to use your example as a like a user case, as a showcase, as an example. So that will encourage more participation in terms of continuous improvement or productivity improvement projects. Oftentimes, productivity and efficiency is confused, so do not try to confuse these two uh, definitions. That is, productivity and efficiency. Well, you can try to make your a part of your process or a small part of your process very efficient, but that might have adverse effect on your productivity. So do not try to confuse these two terms. So these are the 7 key areas where productivity can be improved. Now let's solve the problems over here. So the very first is, I'll just read it out and then I'll be using Excel to solve these. So the very first problem states a catering company prepares and served 350 meals at an anniversary celebration last week using 8 workers. And the week before, so prior week, there were 2 workers who prepared and served 230 meals at a wedding reception. So again, I'm assuming in this case, what they call it as meal are exactly same. You see 350 meals and 230 meals. So I'm assuming the content of the meal was exactly same in both the event, that is anniversary celebration and wedding reception. So again, as per if I quickly glance through, so in the last week, 350 meals, 8 number of people. So this is an input, this is your output, this is your input. And the week before, there were two workers. So this is again input for the week before, and 230 meals served at the event. So this is your output. So the first question is calculate the labor productivity for each event, and second question is which event was the labor productivity higher. So again, like was it anniversary or wedding? So going to the Excel sheet over here, and again, this is a very simple problem. We can it's a we can do a straightaway calculation. But as we move forward, we'll be building on top of this basic. So let's see. So I'm systematically stating down, separating this problem into these 2 different events. So I'm listing out the event. First is anniversary, second one is wedding. The output in either of those, anniversary was 350 meals prepared, and for wedding 230 meals were prepared. Input is number of workers for anniversary were 8 and a number of workers for wedding were 2. So again, as per the definition of productivity, which we saw somewhere here, is straightforward, output upon input. So in this case, it's very straightforward. Only one input is there and one output is there. So all I will do is productivity I'm giving in terms of equals to my total output, which is 350 divided by 8. So like per worker, the number of meals prepared were 43.75, or if I round it up, it's like 44. And same thing for anniversary, I'll just drag this down. It will be 115. So for a wedding, each worker prepared 115 number of meals. So obviously, if we look at the numbers, assuming everything else was same, definitely the workers at the wedding ceremony were much more efficient. So that's my answer over here. So going back, calculate our labor output and anniversary wedding. So definitely, this is my answer. So the labor productivity was higher for wedding, and this is the number. So this is the first problem. Second problem is it stated that a manager of a crew that installs carpeting has tracked the crew's output over the past several weeks, obtaining these figures. I'll just make this part bigger. Let's read through and understand what is given and what is expected as a solution of this problem. So again, in this table, series of weeks is given: week 1, 2, 3, 4, 5, 6. So sequentially, this information is given. Number of crew members that were working each week. So week 1, 2, week 2, 4, week 3, 3 number of crew members, week 4, 5, week 5, 6, and week 6, 7, and yards installed. So this is the output given: 100 on week 1, 67, 97, 47, 67, 56 for weeks 2, 3, 4, 5, and 6 respectively are given. So again, the question that is asked is compute the labor productivity for each week. So for each week, what is the labor productivity? So output upon input, which crew size works best? And again, I'm assuming best meaning which crew size gives the maximum output is the question. So similar to the first problem, again, I'm going to the Excel sheet, and let's see. I'm sure I created this. If not, so I'm looking at 317. Yeah, here you go. So this is the exact table, and again our goal is to compute the labor productivity. So again I'll say this is my labor productivity, LABOR productivity, and yeah, as per our formulae that we have seen in the slide number 33, it's output upon input. So here no like dollar detail are given or and so on. So we'll just use the simple formula over here, which is output upon input, or with partial measures I will use output upon labor. So here my output is 100 yards installed. So equals to 100 divided by number of crew members, which is crew in this case. So that gives me 50. So again, I will drag again, let me use standard formatting. Center, yeah. So for week 1, this is my labor productivity. I'll just drag this all the way down. And again, yeah, these are the numbers I'm getting. I'll format, try to keep it 2 or 3 decimal points. Yeah, let's go with number. For now, I'll stick with 2 decimal points. So yeah. So looking at these numbers, week 1 labor productivity is 50, week 2 is 16.75, week 3 is 32, week 4 is 9, week 5 is 11, and week 6 is 8. Yeah. So looking at, and again, well, this is a big variation I'm seeing. The minimum I'm seeing is 8. The maximum is 50. That's a huge variation. Assuming well, the level of difficulty for these is the same. Assuming the amount of work they are doing, each of the crew members is doing the same. So this is huge. But again, there can be n number of factors that might be affecting this 50 versus 8 and everything in between. So going back to what we are trying to solve. So the question here is compute the labor productivity for each of the week. Yeah. So this is your first answer, answer A. This is the labor productivity for each week. And second question is which crew works the best, meaning which crew gives the maximum labor productivity. So definitely the crew in week number 1 is giving me maximum. So that's my answer over here. So clearly, yeah, right here, A and S for A is calculated above in table. Sorry. Above table. And for B, my answer is, I'll just specify A and S. B is crew in week 1 works the best. And even this can be subjective. So I'll clearly specify gives the maximum output among the 6 weeks. Yeah, or yeah. Just trying to be specific over here. So this is my second problem solved. Next one, yeah. So here the problem reads, compute the multi-factor productivity measure for each of the week shown for production of chocolate bars. Assume 40 hours a week. Yeah, so yeah, 40 hours a week and an hourly wage of $16. Overhead is 1.5 times weekly labor cost, and the material cost per pound is $9. Yeah, so this is what it is given. And again, if I try to, let's make this bigger and try to understand what is given. So again, there is this table, and on the left, like very first column, you are seeing week 1, 2, 3, 4 in a consecutive order. Second column says output units of chocolate bars. So week 1, 32,000, week 2, 37,000, week 3, 28,000, week 4, 38,000, the chocolate bars made. Third column is workers worked in that week. So 5 workers, 6 workers, 6 workers, and 7 workers in week 1, 2, 3, 4 respectively. Fourth column is materials used in pounds. So first week is 470 pounds, 520 pounds, 480 pounds, and 580 pounds used respectively for week 1 to 4. And here is like more 40 hours work week by each of these 5 employees. So that makes 5 into 40, which is 200 hours spent in week 1. Similarly, 6 multiplied by 40, 6 multiplied by 40, and 7 multiplied by 40 for week 2, 3, 4 respectively. And materials pounds, and again cost per pound is given. So if I have to get material cost, I will multiply this 470 with $9, 520 with $9, 480 with $9, and 580 with $9 to get the material cost per week respectively for week 1 to 4. And on top of it, overhead cost is also given. So I'll have to add one more column saying overhead cost and multiplied 1.5 times of labor cost. So 1.5 times each of this, like 5 multiplied by 40 hours. So it will give me the overhead cost. And the main question is compute the multi-factor productivity. So again, if I look at the most basic formula output upon input, my main output I'm looking for is the output units produced. So this is straightforward given. And if I look at the cost, well, no cost of chocolate bars is given, so not a problem. If I look much more on a detailed level for the inputs, so again, worker is given, material is given, and again, cost, irrespective cost for them is also given, and also overhead is given. So here I have 3 different inputs and 1 output. So let's go to our Excel sheet again and try to solve this problem. So again, I'm looking at 5-17. So I just copy pasted all this information in a tabular format. And again, I will encourage you to get used to Excel. It helps a lot. And as you go on, you can build on top of this, and you can add. See, for example, week 1 to 4 is given in this case. For your own organization, you can add whatever, like week 5, 6, 7, 8, and all. You can incorporate all the weeks for the year, and you can have unit stays down for each of this week, and what are the resources that go in. Say it could be number of people, it could be material spent, it could be equipment use, and so on, and cost, and so on. And you can try to formulate your own process, and that's the reason. So coming back to our problem, I have copy pasted exactly the same numbers: 32,000, 37,000, 28,000, 38,000, and so on. Workers same 5, 6, 6, 7, material, and so on. And let's solve it in more detail. So based on this input given, I will just in the very first column, I will calculate the labor cost per week. So here for me, number of people working are 5, assuming 40 hours per week, and $16 hourly wage per employee. So I just plug that those numbers over here. So my labor cost per week will be equals to number of labor, which is 5, multiplied by each of that labor is working 40 hours. So multiplied by number of hours, which is 40, and multiplied by hourly cost. So $16 per hour. 16. So that gives me so $3,200 was spent on these 5 employees in week 1. I'll just drag that formula all the way down. Let's see. This is correct. 40 and 16 are constant. Next one, yes, C5 and 40 and 16 are constant. Last one, C6, 40 and 16 are constant. So this is my labor cost per week. Next one is my material cost. So again, here material in pounds is given, and here there is material cost per pound is given. So if I multiply all these LBs, pounds, into 9, it gives me the material cost spent per week to produce these many number of quantities of chocolate bars. So equals to 470 multiplied by $9 per pound. So it gives me, this is my material cost. So I'll just drag it all the way down. Let's double check here. D4 multiplied by $9 Next one, D5 multiplied by $9, and next one D6 $9. So this is my material cost per week. Third one is my overhead cost per week in terms of dollars. So here it's given 1.5 times weekly labor cost. Yeah. So again, 1.5 times multiplied with this gives me my overhead cost. Yeah. So I'll again use equals to 1.5 multiplied by, again, here I'll use the same way, like a weekly labor cost. So this is my weekly labor cost for week 1. Enter, and yeah, I'll just drag the formula all the way down. So here I got all the overhead cost over here. So just looking at here, I'll just make this bold, standardize. Maybe I will highlight, well, again, these are the calculated entities, right? So I'll just highlight it with a different color, say, yeah, let's use orange. So these are my calculated variables or calculated, yeah, input. So the main question is compute the multi-factor productivity measure for each week. Yeah. So again, week 1, week 2, week 3, week 4 multi-factor productivity is what I'm trying to calculate. So yeah, looking at these numbers, I have all the entities. So yeah, let's plug in to our basic formula, that is output upon input. Yeah. So again, my output equals to 32,000 divided by, here I'll just do sum, or yeah, sum of all these 3 inputs: labor cost, material cost, overhead cost. Selected, close the bracket, enter. So my multi-factor productivity for week 1 is 2.62. And I'll drag this formula all the way down. I'll just double check. Yeah, this is B4, which is this. Here was sum of if, yeah, F4 to H4. Yeah, correct. Same. My formula is B5 upon. So B5 upon sum of these looks correct. Third one, sum of B6 upon sum of all these 3 inputs. So yeah, these are the answers I got for each week. So yeah, that's the question. So there is no comparison asked. They didn't ask like which one had a most or best. But again, looking at these numbers, looks like my week 1 was giving me the most multi-factor productivity. So yeah, like with this week, we solved this problem, is part of the problem, that is computing the multi-factor productivity measure for each week. Yeah, so this completes our this problem. Maybe I'll just make it bold. Yeah, so you see, right? I mean, this time we added some more complexity as compared with the previous problems that we have solved. And yeah, we are able to see some more happening, right? I mean, much more detailed information. And again, there is certainly a variability, highest being 2.62, least being 2.01, and there are few with very close to these. And yeah, there is one somewhere in middle, and there is one extremely low. So the next step would be questioning why this is happening, why I'm getting the best in some week and why I'm getting the least in some week. So these are your opportunity points. But yeah, for now, we'll just stop here. So this is the next problem that was solved. Going to our PowerPoint slide again here. Let's read and solve the next problem, which is, yeah, this one, 7-17. A company that makes shopping carts for supermarket and other stores recently purchased some new equipment that reduces the labor content of jobs needed to produce the shopping carts. Prior to buying the new equipment, the company used 6 workers who together produced an average of 70 carts per hour. So input is given 6 workers, 70 carts per hour was the output. Workers received $13 per hour. Machine cost was $50 per hour. With the new equipment, it was possible to transfer one of the worker to another department, and equipment cost increased by $11 per hour, while output increased by 5 carts per hour. Yeah. So again, some more level of difficulties has been added. So we will yeah, try and solve this problem as well. Yeah. And yeah, the few questions that are asked is compute labor productivity under each system. Use cart per worker per hour as the measure of labor productivity. So that's the first one. B is compute the multi-factor productivity under each system. Use carts per dollar cost, labor plus equipment as a measure. Okay, yeah, so clear instructions have been given. And yeah, third question C is they are asking for comment on changes in productivity according to the measure. Yeah, awesome. Yeah, this sounds like a very interesting problem to solve. So yeah, let's move forward. So yeah, if I read the whole thing, so there are two cases given. One is old way of doing, and another is a new way of doing. In the old way, or say current state or previous state, maybe some old style machinery was used, and there are 6 workers here. So let's formulate this in a systematic manner using Excel. So I'll just do half and half, and here we are. I think yeah, I have copy pasted this same information or created same information. Okay, yeah, here you go. So yeah, systematically, like we are formulating in a problem in a systematic manner. So I'll use this, center it down. So in the previous case, yeah, it's given 6 workers were there. Yeah, so again, I said 6 workers, and number of cars produced by them per hour was 70. So I written 70 over here. And some costing information is given, pricing information. So worker received $13 per hour. So I written it over here, $13 per hour. And cost of machine cost is given as $50 per hour. So I written it over here. So this was the previous or before state or current state, and you're trying to find the new state or future state or here. So for that, this is the information that is given. So they are saying with the new equipment, it was possible to transfer one of the workers to another department, meaning the same amount of work is done by one worker less. So again, with the new condition, they are only using 5 workers. And the last statement says while the output increased by 5 cars per hour. Yeah, so previous output was 70, so increased by 5 hours. So I'm adding this 5, so it becomes 75 cars per hour are produced with the new equipment. It says the equipment cost increased by $11 per hour. So I'm adding previous was 50. I'm adding 11, so it makes like 61 dollar per hour as the new cost of machine. And nothing is given by about the worker. So assuming it will be the same. Yeah. So this is the information given. So again, the first one is compute the labor productivity under each system. Use cart per worker per hour as the measure. Yeah. So again, pretty straightforward answer, right? So in the old system, 70 carts per made by each worker. So yeah, that gives me the labor productivity. So again, straightforward formula equals to, this is my carts per hour clearly given in your statement over here, carts per divided by number of workers required per hour to make the carts. Yeah, so that gives me my labor productivity of 11.6, or 11.7 if I round it up. So that's my first answer. And in the same way, same thing applies for the newer case, right? So yeah, so for each case they are saying. So I'll just drag this formula that gives me So definitely with the new equipment, I can see the number of cards made per employee have increased from 11.6 to 15. Yeah, so again, that's an increase. Second question says compute the multi-factor productivity under each system. So for both before and the new, let's say previous and the new, we are supposed to compute the multi-factor productivity, use cards per dollar cost as the measure. Yeah, so that's what we are supposed to do the measure. So the very first is the cards per measure. So multiple, so cards per dollar. So number of cards made, right? So equals to number of cards. I will just use this number 70 divided by. So here we'll be having a two segment of input. First one is worker and machine. Yeah. So the labor cost here is number of employees 6 multiplied by cost spent on them, which is $13. $13 per hour. So that's 1. Maybe I'll use double bracket out here because yeah, we have 2 inputs plus machine cost per hour, which is given 50. Yeah, so in 50, so I'll close both the brackets. And oops, there is a problem. Yeah. So yeah, as per this, I am getting my under each system as a measure. Yeah, cards per dollar. So for every dollar spent, I'm able to make 0.54 cards as per my previous system. And if I do the same calculation here, I'm getting 0.59. Yeah, so definitely per cart, this has increased under the new this equipment. Let's just format it out. Two decimal. So yeah, 11.6715. And with respect to cards per dollar cost, I'm getting 0.55 for previous and 0.6 for new. Third question is comment on the changes in productivity according to the two measures. Yeah, so again, I will go few slides back and look for the productivity formula, which is I think here, not here. Yeah, here. So productivity growth, right? So current minus previous divided by previous into 100. Yeah, so my current minus previous divided by previous into 100. Yeah, so that will give me my productivity growth. So this will be equals to my current, which is I'll start a bracket 0.6 minus previous 0.55 divided by previous 0.55, and again everything I will multiply by 100, or I can use in a formatting percentage. Yeah, let's do here only multiplied by the whole thing multiplied by 100. So that's the percentage. So yeah, my productivity increased by 8.8% is what I'm getting. Yeah, 8.84% productivity improvement is what I got using the newer equipment. So yeah, this is how I will be solving. And again, let's make it presentable, the whole thing. So I'll say format line border. Use this line border, and let's add some comment over here. Yeah, compute. So cards per dollar cost. Yeah, so that's my B. Cards per is the measure I'm using. So yeah, this is how I'll be solving this problem. Let's move to the next problem. Yeah, numerical problem 9-17. So it reads an operation has a scrap rate of 5%. As a result, 38 sellable pieces are produced per hour.